Hello, my name is Justin Belk, and I'm with the Washington State Department of Transportation. Good morning and welcome to the ITS Washington Annual Conference. Thank you for joining us virtually this year. Again, we would like to thank our platinum sponsor, CT Northwest, for their support of this conference and the virtual platform itself. Make sure to visit their virtual booth by clicking on the Exhibitor tab in the menu on the left side of your screen. Please take a few minutes to visit them and see what they have to offer. And now I would like to introduce our speakers. As you know, freight and intermodal facilities are experiencing some challenges and constraints that they haven't had before. And so I'm glad to introduce this panel, a mix of people from the State Department of Transportation, touching a little bit on the research side as well, and also from our port community. So first we'll have Jason Beloso. He is the strategic manager of our Rail, Freight, and Ports division at WSDOT. We also have Karthik Murthy. He is in our transportation operations headquarters division. And Frank Yang from the University of Washington, PhD student at the STAR Lab, will help answer questions on some research him and Karthik have going on. And then we'll have Christine Wolf talk about her perspectives from the Northwest Seaport Alliance. Thank you.
Great. Can everyone see my slides?
Yes, they look great.
Fantastic, thank you. Good morning, everyone, and welcome to the 1st of December. My name is Jason Beloso, as Justin had mentioned, and I'm the Strategic Planning Manager for the WSDOT Rail, Freight, and Ports. Like Justin also said, freight is facing many challenges, not just in Washington State, but also across the country and internationally. The most prevalent being supply chain. You may have heard a lot of the news on a nightly basis around supply chain issues. My presentation here today will cover an aspect of that, truck parking. I will focus on the macro side of truck parking for those that aren't too familiar with the topic. And then colleagues, Karthik will cover the micro side of the truck parking topic. And then Christine will talk a little bit more about the broader supply chain issues from the port perspective. So let me begin by providing a little bit of an overview to the problem. So when we talk about truck parking, there are a few driving factors to consider. One is hours of service. So for a truck driver, truck drivers are regulated by hours of service. That means how much they're able to drive, and then requirements for when and how much they rest. Long story short, those hours of service do require truck drivers to take rest breaks for short periods as well as overnight sometimes, particularly for long haul drivers. There's a supply and demand issue as well with the amount of trucks and drivers that we have and being inconsistent with the amount of facilities where a truck driver can stop for the night. There's also a land use issue that's driving the problem, and that's particularly in areas like Puget Sound, where those that are more expensive to build, say truck parking facilities, that's where you see your truck parking deserts. Because of that lack of supply or limited supply, maybe you saw it last weekend driving to grandma's house to have Thanksgiving, trucks being parked on the side of the road, on ramps and off ramps. Those are not the places where truck drivers prefer to stop. They pose a risk, not just to the truck driver themselves, but of course the general motoring public. There's also a safety and human welfare aspect in that these folks we depend on to deliver the goods and services that we tend to rely on. But oftentimes their only option for parking is on the side of the road. So that's a particular issue that we want to focus on. There are several efforts underway from the federal level down to the local level. There's a federal Jason's law requires states to take a closer, harder look at how to address the truck parking issue at a state level. States have also banded together to look at this problem from a corridor perspective. How do we ensure consistency and alignment? with the work that we do with regards to truck parking and implementing ITS solutions. State and regional priorities becoming more of a key focus area for many of the partners, as well as private sector, and increasing public awareness is also happening at the same time. A few of the mechanics here with regards to truck parking, again, like I said, those truck parking deserts, primarily in areas where you have urbanized areas, where areas that are also cost prohibitive to build these truck parking facilities. You see that in the image on the left here, where the orange sections really kind of show where there's a lack of supply for truck parking, again, mostly in the urbanized areas and border crossings in Washington state. On the right-hand side, for the lucky few, a small percentage of truck drivers are spending about 15 minutes looking for that parking space to park and pull over safely at night. A good third of them spend about 30 minutes, and more than half of them spend approximately 60 minutes looking for a truck place to park at night. And for the unlucky few, about a quarter of them spend well over 60 minutes looking for parking. What does that mean? That means that these folks aren't getting paid because it's not the miles that they're getting paid for driving the truck. It's also additional use on the gas. And as you know, gas is very expensive these days. And so that's a problem, right? And that's why you're seeing some of those trucks being parked on the side of the road. There are technology applications, ITS solutions available for truck parking, and Karthik will go into greater detail about some of the mobile app projects that we've been working on. But other technologies that apply to truck parking include variable message signs, reservation systems. Think about it like when you're going to a camping trip with a family during the summer, you don't pack everyone up in the car and expect to pull up to your camp spot and have it be open for your use. You plan well ahead before you get in that car and you make those reservations. Similar here, where a truck driver, say, does a run from Chicago to Salt Lake City. He's going to try and plan for where to stop, knowing what his hours of service are and where his destination ultimately will be. These truck parking applications and information is also being integrated into a lot of the route planning and in-cab systems by the OEMs. And then the data collection and sharing, that's becoming even more important, particularly for the public sector side, where that could help us inform how to best develop and implement some of these truck parking solutions. Now, with that in mind, there are several initiatives, again, that has a crosswalk between truck parking and ITS. One is the 2016 truck parking study that the agency conducted. It's getting kind of old, and so we're going to be looking at updating that here pretty soon. More recently, over the summer, we conducted a truck parking workshop along with FHWA, and I'll share the results of that here in the next slide. Currently, the Joint Transportation Committee is working on their truck parking action plan. The results and recommendations are expected here pretty soon, in the next month or two. And so I would expect to see recommendations that also have ITS applications or implications there. And lastly, on the initiative and planning side, the agency is updating the 2022 state freight plan, and we will focus on truck parking as well. There are other actors that look at truck parking, not just the DOT. PSRC, Puget Sound Regional Council, has a freight advisory committee that's also focused on truck parking. And like I said, multi-state coordination, particularly along the I-5 corridor between Oregon and California. So this slide shows a little bit about the discussion that we had and some of the technology solutions that came up at the summer workshop. So one is developing that reservation system at state-owned facilities. It seems simple, but it's really not. A lot of the issue relates to the enforcement side of that. And not to mention that there are limits and regulations regarding commercial services at our safety rest areas, publicly owned safety rest areas. So it sounds like a simple solution, but it's really quite a challenging puzzle to solve. Collecting and analyzing the data to identify hotspots, that's an important piece. It's not a system where you build it and they will come. There are reasons why trucks and truck drivers park where they park. It could range from they want to stage and park at night so that early in the morning they have direct access to either the port gate when it opens or the manufacturing industrial center where they have to deliver the goods. It could be a function of their hours of service where they just run out of hours of service and they simply have to stop. Their option is to get an infraction and possibly jeopardizing their commercial driver's license. So it's not a system where you build it and they will come. And so really identifying and understanding where these trucks kind of need to stop and where they tend to stop, that's really important to understand. And then another one I'll pick here on this list is assessing the benefit costs of these proposed technology solutions. I know that this slide covers quite a bit of information, but my intent here was to kind of show the different efforts and initiatives by other states across the country and the different solutions that each of these states have implemented, and they do range quite a bit. The partners have included not just the DOTs, but research centers, OEMs, public sector as well. They've looked at anything from one site to multiple sites, different types of technologies such as camera systems, validation systems, GPS, and in the case of Tennessee, even Doppler radar and side laser scanners. The way that information is also pushed is also very different. Anything from websites, mobile apps, again, to variable message signs. The key there is that from a user or truck driver perspective, what you really want to key in on is how that user is accessing and receiving that information. For a long haul driver, what we're trying to avoid is making sure that when that driver drives through one state that he may be using and powering his laptop to open up to access the information, truck parking information, he moves on to the next state, and that state is only projecting their information through a mobile app. He moves on to that third state, and that state is only using variable message sign. So that's very problematic for a truck driver. You need to have some consistency in how that information is pushed. And as you can see here, not everyone is looking at reservation systems because of its complexity. But I think many states are looking to see how that would work. Last few slides that I have, just kind of expanding the conversation a little bit more. There was a recent NCHRP scan that looked at truck parking as well, looking at best practices, successful approaches for facilitating and accommodating truck parking. So I wanted to cover just some of the recommendations that came out of that. Again, stressing the importance of identifying where those needs and locations are very, very, very important. Utilizing those appropriate sensing and validation technologies. And Karthik's going to go into this a little bit more. What we're trying to get to there is making sure that when the system says you've got 5 spaces available and you may be 10 miles out, that when that truck driver actually gets to that location, that there are indeed the number of spaces that the app said there is available. Otherwise, it becomes a little bit less useful for that truck driver. So that validation technology is also very, very important. A couple other, I think, really good recommendations that came out of that scan tour is, yeah, you may be working with your planning folks, you may be working with your traffic folks, but make sure you also include other divisions or offices within the agency, such as your maintenance, your procurement and programming. Those folks also play a key role in developing your IT solutions for truck parking. Of course, engaging the feds and other state partners, corridor coalitions, also very important and can help to successful truck parking solution implementation. And again, I think just lastly here with regards to that maintenance side of things, making sure that these systems, once they're built, that they continue to operate in a state of good repair and including them in asset management plans. Really important to keep in mind as we look at it from the front end, the planning and the implementation side, just being mindful of that maintenance side of the conversation as well. Lastly, I'm going to end here. I think the scan tour, because of the fact that it looked at best practices, I will leave you with this link for the scan tour scan results, domesticscan.org. My information is also down below. If you have any additional questions, I can be reached through my email address. And so with that, thank you very much. I think I yield over to Karthik.
Thanks, Jason. All right, can everyone see and hear me?
Yes.
Yes.
Great. Okay. All right, so today we are going to be talking a bit about a truck parking pilot project that WSDOT has been working on with the University of Washington. As Jason has mentioned, one of the areas that we've been interested in is really just deploying this technology to determine what space availability information we have available, and then just making sure that we're able to get that information out to the public so that they can make their decisions on parking and that availability and, you know, with their route planning. So today I will be talking a bit about what we're doing here with our truck parking information management system, some of the work that University of Washington has done with their pattern analysis and availability prediction, and just what we plan on doing moving forward with the great work that University of Washington has done with the parking pilot. So as Jason mentioned, there was a truck parking study done in 2016 that surveyed about 1,000 truck drivers. And one of the findings from there was that we really needed to get this truck parking information out to the public for their parking availability and information. So with that, what we additionally found was that, you know, we have all of these parking spaces, and the availability of those spaces has become a huge issue with the increase on freight traffic and that sort of thing. And when we look at the research that is out there these days, most of the parking space availability information and utilization studies have primarily been done on urban areas and urban parking facilities, and not so much has been done with the truck parking facilities that we find in rural areas and that sort of thing. So with this study that we've been working on with University of Washington, we've really tried to, one, figure out how we could get this information out to the public and just get our understanding of this parking behavior. And with that, we have put together this pilot truck parking information management system that can really be broken down into three portions. One being the parking detection, so being able to determine when the space is full based on you know, occupancy by trucks, and then taking this detection information and putting it through an availability prediction algorithm, which University of Washington has done great work on, and I'll touch on some of those findings, and they'll be available for questions at the end of the session. And then getting this prediction information out to the public through a website or a cell phone application. And I'll go through some of the websites that University of Washington has developed towards the end of my discussion. So with that, when we look at detection, there are really two schools of thought, if you will, for how we can do this. One being just putting sensors at the ingress and egress of the parking facility. So while this parking detection system can be cheap in that you're only really detecting vehicles at the end at two locations within the parking facility, you can really start to see errors accumulate over time as, you know, vehicle parking events are missed due to close following or any sort of other issues that may occur to prevent the detection of vehicles over time. The next parking detection system is a slot-based system where we have parking detection within each parking stall at the facility. And while this system can be very accurate, it's usually expensive when it comes to things like the installation or the asset management piece when we're looking at the maintenance needs for detection sensors in each of the parking stalls. So for the pilot that we developed, we decided to go with the with the slot-based detection system, just because we knew that accuracy there would be pretty good to manage. And our primary focus here was looking at the development of the algorithm and prediction piece. So here are some pictures of the in-pavement sensors installed at the location. These ground sensors send information to a repeater, and that repeater sends it to our backhaul, which then sends it to the information server where the algorithm is run, and that prediction piece is deployed through the website. And we had a real-time video also installed just for some validation of the sensors initially to make sure that the detection accuracy of the sensors that we installed was on par with what we needed. So for this pilot, we chose 2 parking facilities, one being the Nisqually Way Station on I-5 northbound. There were about 12 parking stalls at that location. And then the second being the Scatter Creek Safety Rest Area, also on I-5 with about 37 rest areas. Each stall required 2 parking sensors. And depending on the configuration of the parking stall, we had to have multiple repeaters installed on poles to be able to pull this information and send it back to the database. So with that, during our data collection system, we had to really look at a few pieces of information, one being the occupancy percentage. So we took in information from these sensors to determine how full each of the parking facilities were. And then also being the date and time and the weather. And for weather, we looked at classifying each time period as either sunny, cloudy, rainy, snowy, or wintry mix of fog, and that was taken into consideration for the algorithm that I will touch on in a couple of minutes. So we also looked at just analyzing the data, looking at patterns in the occupancy rate, where we would see these on and off peak parking times where the occupancy rates would be higher during the nights and lower during the days. And then also looking at the same type of behavior of where we were seeing the high and lower occupancy rates based on the weather, the time of day, and the day of week. And from that preliminary analysis, we also looked at mapping it out this way to see where we were seeing any of the higher occupancy rates. So again, during the weekdays, we were really seeing the nighttime parking occupancy rates go fairly high, and it was variable to low during the off-peak and weekend hours. So again, talking about the similarity analysis, when we looked at time of day and day of week, for this time of day period, we really saw an off-peak hour and a daily peak hour. And you can see here that this similarity analysis pretty much held true based on the comparison here that shows our off-peak hours very similar to each other, and our peak hours very similar to each other as well. A similar pattern can be seen for the weekly analysis, where we see, a working mode and an off working mode, where weekdays tend to be very similar to each other and weekends tend to be very similar to each other as well. So from that, we took all of this information and put it through what we're calling the truck parking occupancy prediction algorithm, which took in these attributes that we're talking about, this time of day and day of week, as well as the historical information from the parking behavior in the hours preceding the prediction time that we're interested in, to really determine what parking availability we expect to see and how confident we are in that prediction time. So this is just a visual representation of this algorithm, taking in some of the attributes, the time of day, day of week, and weather, as well as some of the temporal features for previous parking behavior, and bringing that into our prediction mechanism to get our predictions at the given time interval that we're interested in looking at. So based off of that, when we looked at the various times, we looked at 10 minutes, 30 minutes, 1 hour, 2 hour, 3 hour, and 4 hour. And based off of the analysis that University of Washington was able to do, we were really maxing out at an error of about 11 to 12% at the 4 hour mark. So this was pretty promising for us in that, as we move forward, we obviously want to look at improving this time prediction and accuracy. But at this point, we are very optimistic in being able to predict at that time period out with that level of prediction accuracy. So what we were able to really look at this when we looked at some of the data that we were getting was that, yes, truck parking is heavily impacted by the time of day, day of week, based on the data we were able to collect. When we looked at including and excluding the weather information, that did not really have too much of an impact to prediction in Washington State. But if we were to look at any other locations in the country or anything like that, weather may have an impact on parking behavior. So it'd be interesting to see how this prediction algorithm behaves with parking data at other facilities and other locations with different weather patterns. Another thing to note was that for some high extreme occupancy situations where we were having about 95% or greater in occupancy, we need to look more at capturing some of the finer changes in the parking behavior or the prediction itself to be able to capture those within our algorithm. And then another thing to note was that when looking at the off-work mode, the predictability of the parking behavior is much lower, and that average parking behavior is short, with less than 10 minutes, and that illegal parking and other factors may impact the parking behaviors of those vehicles at that time during their off-work mode. So with that, I'm going to show some of the work that UW has done in developing the websites that they worked on. So, this is just a pilot website where we've got some of the home information, giving information on just Washington State parking, that what we have available. And one thing I really want to highlight is this real-time parking screen that we have here that really shows, at a given time, what slots are available at the facility and the number available, and our, confidence in the availability at those hours, at those minutes and hours from the current time. So this was really interesting in being able to get this information out there. And I will go into a little bit about what we plan to do given the information that we have now. So given what we have with our prediction algorithm, we obviously want to continue to work on improving the prediction time and accuracy. So that goes into how can we predict, at 18 hours ahead, providing that information to route planners and that sort of thing. That would be really helpful to people managing vehicles and all of that. So the next bit is looking at parking space reservation systems. So Jason alluded to some of that discussions that have been going on, but is that something that we could include in this, and how would that impact anything that we have within our algorithm as well? And the last bit is also looking at route planning, where if we have an origin destination based on the prediction and the confidence in having parking spaces available, can we provide an ideal route for a vehicle going from point A to point B and just direct them to places where they would have parking spaces available? So these are some things specific to the algorithm and application that we are going to be looking at. And as we look, globally, if you will, at truck parking information management, some of the things that we want to look at include, improvements on the detection systems. So as I spoke, we had the slot-based and the egress-based systems, and we'd be interested in looking at some sort of mixture of the two, where we're getting the cost benefits from having fewer sensors deployed, but we use some sort of AI application to be able to get information and improve the accuracy, if you will, of egress systems as well. So that is something that we want to look at as far as different detection schemes that we could use to improve on both the cost and asset management piece as well as the prediction accuracy. Then, as Jason alluded to, we'd also gotten some information from these truck parking workshops and seeing the interest in wanting to deploy some of these systems. We want to obviously build up on that collaboration and continue to have these discussions with state, local, regional partners to really deploy a system like this more broadly. And then within Washington State, we just received a grant from FMCSA to deploy this parking detection systems to 28 facilities, state-owned facilities on I-5 and I-90. The grant itself will be used to, one, deploy these detection systems, and then do some user testing. So being able to put this in front of commercial vehicle operators and planners to gauge usability and improve on those pieces. And then also look at doing some algorithm updates based on new information that we can put into the algorithm, and also make updates to the application itself as we look to expand this to iOS or develop an API that could be used by information dissemination systems and that sort of thing. So with that, I will throw it over to Christine for her to have her discussion on her work.
All right, let's get this show on the road. So I'm going to completely switch this on you. No more truck parking. Again, my name's Christine Wolf, and I'm the transportation planner for the Northwest Seaport Alliance, and I'm glad to be here today to spend some time with my colleagues on the stuff I do and proselytize a little bit. So I thought I'd start very briefly with an overview of what we do. I imagine not everybody knows ports all that well, except for a few folks like Jason. I work for the Northwest Seaport Alliance, which is an operating entity by the ports of Seattle and Tacoma. We manage the container terminals and some of their other bulk and break bulk facilities for those two ports. So if you live in King or in Pierce County, I work for you. Oops. Just really, this is too far. So here's the geographic location. We have facilities in Seattle and in Tacoma. right now we're the third largest, the fifth largest container gateway in the United States, and we are the second largest warehousing and distribution center on the West Coast. We also are the biggest gateway for refrigerated goods. Think cherries, French fries, and all that good stuff being produced in Eastern Washington in the country. Here are our facilities in the Seattle Harbor. Those big yellow circles delineate international container terminals. We also have a facility that serves Alaska and Hawaii. And you can see that we really have very good connections to the freeway system and to access to rail yards. Collectively, all these facilities represent billions of dollars in investment by both the public and the private sector. So when people talk about wanting to get to reduce the size of the manufacturing industrial center, we get really nervous because we spent collectively a lot of money there and we would like to be able to keep using it. Similarly, this is the Port of Tacoma area with 3 international terminals. The other thing that I should note is we also have a major car import facilities here. You can see those cars here. So if you're driving a Hyundai or a Kia, it came in through our facilities in Tacoma. So really briefly, and this is kind of important because it really helps tell the story down the line. Here is the supply chain. You know, stuff gets produced somewhere else. A lot of it in China these days. It gets to a harbor and then eventually it comes to us. And we're basically the area, the bridge between the water side and the land side. And so what that means, we have limited ability to do stuff. We can try and work with our terminal operators. We talk to the trucking firms, we talk to the cargo owners, but we have very little ability to actually influence things. It's just like you own a piece of property that has a restaurant in it. You can lease that restaurant space to somebody running a restaurant, but you can't really tell them what food to make and those kinds of things. Nevertheless, we are trying. Some of you may have seen this before. We have been working for quite a number of years now to implement a port community system, which is basically a platform that tells folks about container availability and what's sitting where and so on and so forth, so that the folks who are on links of the supply chain that touch us can communicate and talk with each other in a more productive way. And we actually, in about 4 years ago or 3 years ago, we actually tried to implement that kind of a system at our facilities. Some of you may have actually been with us in the stakeholder meetings when we discussed and developed a concept of operations that we then put out to bid, and we got 17 responses. But what we found out is that it's pretty easy to get people to do the technical stuff and develop the system that can be used in order to maintain and distribute that information. What nobody wanted to do is say, work with the stakeholders to make sure that they're playing and that they actually provide the data that is necessary to populate the system. You know, the Port of LA spent like $30 million on their system. And with all the congestion news that we hear on an almost daily basis, you can see how well that's working for them. Granted that this is a unique situation at this point in time. So we don't have those millions of dollars laying around. So the risk for us is just too high in implementing that system in one full swoop. So we are in the process of building that system incrementally and with data that we actually have. And in a way, we're slow walking it, making sure that terminal operators and trucking firms and the cargo owners are actually using that information. And so what we've been doing until now is we have a website that we beefed up and populated with information that is useful to the folks who touch the port along the supply chain. And this is a screen, these are a couple of screenshots you can see here on the left. This is the one for cargo operations. And you can see, we got stuff on our terminals, cameras, and truck turn times. That's what you see here on the right. This happens to be Terminal 18 in Seattle. At that time, it took about 40 minutes to get through the terminal. And you can see that there are truck queues on the terminal. But it's relatively fluid. And you can go to our website and look and browse those different tabs. I'm going to focus a little bit more on the truck side of things in the next few slides. You all read the paper, so you know that we've been super busy, just like other ports, because of a glut in imports. And we had a rail backlog, and our on-time vessel performance is in the single digits right now. Terminals are stuffed to the gills with containers, and so they actually slow work the ships, which means it's more difficult for the trucks. What happened was that a lot of folks first were kind of careful when COVID started last year. People didn't order as much stuff. And for example, you've all seen this with the problems that the auto industry has because they canceled their chip orders and now they need them. And it's slow to come back. And that's kind of the same thing on many different items along the supply chain. Folks who in the retail industry went from just in time to just in case. So they were ordering stuff way in advance. They already had most orders for Christmas out in June, and that caused the warehouses to fill up. And then the trailers, what we call chassis, that are used to move containers between our facilities and the warehouses are now in short supply because there's actually most of them are sitting somewhere in front of a warehouse instead of moving. We do what we can. We have off-dock sort of pop-up container yards that are outside of our actual container terminals, and our tenants have extra gates. And to help the truckers with this situation and into the future, we actually are in the process of building a data repository. And we have a company that is building that to our requirements. And it will be used to add data sets to the information that is available on our website. what we call the port community system. And sort of the next item on the list that we're working on right now is on a centralized system managing appointments and providing visibility on truck appointments for all of our terminals. Right now, every terminal does it individually. You have to go to their own terminal, to their own website, and it's not very efficient or productive. So here's how we're going about this. As I said earlier, we're taking an incremental approach, slow walking everything to make sure that we actually can have success. So we're in phase 1 now, proof of concept. We have one terminal in Tacoma that we're using, and where we're using the data to populate the new central system that we're developing. And then we'll expand that to the entire gateway and have a website that can function fully with this data set. And then the next step, once we know that this is working, we can add new data sets to our system and the website as we go along. Quick example, this is what a dashboard might look like. You can see terminal Husky, you can see what time, what type of container transaction, and how many appointments are available. So what we're trying to do with this is, and that's of use to some of you who sometimes have to deal with the truck queues that we have outside our terminals, the truckers and the dispatchers that send them places have a better idea of the availability of appointments, and then can use that information to get better at scheduling those appointments. They can see who's busy, who's not so busy, and if they have any flexibility, they can use that to go to places where they don't have to wait. It also reduces the number of just-in-case appointments. What's happening now is that, you know, say a trucking company has a job for Walmart, they need to pick up 200 cans at a specific terminal, and they all need to get to Walmart at a specific time. And so what a lot of folks are doing now is generally they actually may need only 40 trucks to do the work and get it done on time if everything goes well. But if since there's something that could go wrong, they may actually end up sending 60 just to make sure that they can fulfill the contract that they have. And from our perspective, as I said before, we are validating the technical approach for adding that information to our database and can then use that approach for future data sets. I don't want you to get too excited, though, that we'll fix all the problems in the world with this. This is a slide that shows some of the systems that are in use now along the supply chain, and the port community system is only one of them. A lot of those systems are legacy systems that can't talk to other systems. Many are proprietary and it's difficult to share information. So there's a lot of work that still needs to get done to make the whole system work better. We've been talking to the feds about this for a really, really long time. The recent infrastructure bill that just got passed 2 weeks ago actually has money for this. The Federal Maritime Commission, whose job it is to make sure that things work, actually has started a maritime information transparency initiative to deal with the fact that a lot of that information is siloed and that systems can't talk to each other. So they're going to look at the constraints in the way data move, and they are poised to develop recommendations for data standards and policies and protocols for information sharing with a multi-phased effort. And the first set of findings expected in spring of 2022. And to those of us who have dealt with this before, this sort of looks suspiciously like the front end of what might eventually turn into ConOps. And we're just really hoping that this will work out for everybody. Really briefly, going back on a more local level and to points where we actually touch and work with our partner agencies. Terminal 18 in Seattle has been pretty busy at times. And so we actually developed a congestion management action plan jointly with SDOT and the Northwest region at WSDOT, where we developed a set of options that we could use if and when the terminal gets sticky. And that includes DMS messaging, signal timing, plan changes, and other things. We also provide that information to Metro so that they can adjust their bus dispatch as necessary. We actually help to pay for some of those signals and DMS as part of various efforts that are not necessarily, that were not required as mitigation for projects that we did. We just want to be good neighbors. The other thing that we're doing is, to the extent we have the bandwidth, we participate in the joint operations groups that WSDOT is running both in Seattle and in Tacoma. And our goals is, when we do this, we're interested in both working on the incident management side, but what we really want to get to sooner rather than later is to actually system management, a proper TSMO approach that can help us in the long run manage the system as a whole better than we are able to do today. And I'll close with this slide. Why is doing this so hard? Why is sharing data so hard? And manage to cooperate so hard? And at the port, as we learned when we were trying to implement a port community system in one full swoop, that it's all about people. We can have the technology and set up the system. That's not a problem. It's, in quotation marks, just money. But in order to get this done, and I would pose that it's the same for TSMO, we need to bring the humans along. We need to figure out how to share sensitive data in a confidential way. That means building trust and convincing the lawyers. I've been watching Seattle for many years now, and the fact that it took about 10 years in that area to get something started, and that was public sector only, I think, is that we actually do have similar problems. So, we need to figure out how to tell our leadership teams and the politicians that what we're doing is not just about hardware, that we need the human bodies in the control centers, that we need to pay for data and cloud storage and SaaS on a continuous basis, not just once at the outset. And that in some cases, we need to share that ongoing cost of operation. And the other thing is humans are humans. There are few opportunities for ribbon cuttings. There's no bridge or highway where people can point to and say, I made that happen. And that's true for both a PCS and for an multi-agency TSMO. So, you know, I'm closing with this, hoping that we can all work together to work and make these things happen in a way that's productive and efficient. One of the things that we're working on, and I think that's the same with the folks who are working on TSMO strategies and collaborations, is we need to have performance indicators and data that help people understand that this is worthwhile and that it makes sense to spend money on something you can't really see. And I'll leave it at that. Thank you for listening.
Thanks, Christine. And thanks again to Jason, Karthik, Frank for being here to share with from your experiences, what we're trying to do to help face these issues that are out there. Jason had to get onto a different speaking engagement and we only have a few minutes left. So I want to remind everyone, if you entered your question in a different chat pod or something, be sure to get it into the Q&A tab if you don't hear me ask it. But I will go ahead and we'll get right into this first question here. It's for Christine. Can you expand on how port stickiness bleeds over to cause congestion for buses and cars? And you mentioned, you know, being a good neighbor, and but of course, you know, there can be port operations that do spill out of your area. And can you expand on that, please?
Yeah. So what's happening is ever since 9/11, we now have a requirement for the truck drivers who enter our terminals. They have to have a transportation worker ID card. It's sort of similar to what you have if you want to get in the fast lane at the airport. They basically do a criminal background check and make sure that everything is okay. And none of our terminals was developed to take that into account. So we have a bottleneck at the front end at the entrance to our terminals, where our terminal operators have to make sure that everybody has that card and is a valid driver allowed to enter the facility to ensure safety and security. We do have truck queuing areas to deal with the system on the port, but it still happens that we stick out. And we had some situations where at T18, for example, with the glut of cargo, until the terminal rearranged how they're managing it, where we had truck queues on the northbound off-ramp on I-5 to get to Harbor Island. And obviously that's not a very safe situation. It's also not particularly good because they are on the surface, and you know, the high bridge to West Seattle is closed to traffic right now. So there's a lot of pressure on the low bridge. And if we have trucks queuing in the right lane in the westbound direction, it doesn't help the buses who need to get across that bridge. So that's what I'm talking about. What we're trying to do is to minimize the truck queuing that takes place outside of our facilities. It's not parking, it's queuing, but you know, it sort of has a similar effect on folks, and we're trying to avoid that. And obviously at the same time, our business partners, it helps them because it's a more efficient and reliable way of getting their cargo or taking export cargo to our facilities if we're not backed up.
Thank you. One more question for you, Christine. You touched on joint operations groups and how important operations stakeholder coordination is, and you investing in DMS, VMS off your area. But I want to commend the partnership between Port of Seattle, that North Harbor, South Harbor, Northwest Seaport Alliance partnership. Is that a common thing that's catching on with ports in other metropolitan areas that, because it seems like that's been a huge benefit for coordination of freight in the region. Have you been seeing that kind of partnerships elsewhere?
No, we're sort of the only ones. And that was in part a result of the fact that before we joined as the alliance, we were sort of competing for each other's cargo, and it was kind of a race to the bottom. Neither of the ports is by themselves is large enough to be able to actually support that. And it also doesn't really help us fulfill our mission, which is to help grow the economy and grow and maintain good paying jobs in the counties that we serve. So it was kind of a no-brainer, but obviously, you know, when you do something like this, it takes a while to get organized and to get over the hump that you've been competing against each other for many years, and now you're working together. But you know, we're doing it.
Yeah, that's great. Before we go, I want to give Karthik an opportunity. If I heard you correctly, you're looking for other engagement from the private sector to validate detection technologies. So they should reach out to you and Frank if they have, if anyone has a solution that perhaps should become part of this research.
Yes, absolutely. Part of this this grant that we're trying to look at all of the various detection technologies out there and trying to evaluate them and their design constraints with the various parking facilities that we have to look at. We've got about 28 or so across I-5 and I-90 that we're trying to outfit with this detection technology. So yeah, part of this initial effort is going to be looking at what we can do with detection at this point.
Okay, that's exciting. Thanks again to our platinum sponsor, CT Northwest, and I wish you a great rest of the conference. Thanks.
Right.
Thank you.
Goodbye.